this activity, we are going to determine the amount of pressure available at the building control valve. To do that, we're going to take some given information from a project, and that given information will be that the water supply fixture units totaled 35.5 WSFU. The gallons per minute of the building were 22.2 gallons per minute. There is a difference in elevation between the main and the building control valve of 8 feet. We're going to select a 3/4 inch water meter, and we are going to go with a developed length from the main to the building control valve of 75 feet. We'll also use, for this example, we'll also use a low pressure at the street of 58 psi. Alright, the first step of the calc sheet asks us to calculate the water service pressure loss. Step number 6 says low pressure at the main in the street or an external pressure tank, which we do not have. We do have low pressure in the main, and that's actually from step number 5 right above us. So we'll just take that number and we will drop it on this line, and we'll start out with 58 psi. The next step is to determine the pressure loss due to friction in a given or a selected diameter water service. For this example, we will go with a 1-inch diameter water service, and the material we will use for this particular project will be type K copper. The next thing we will do is we will determine what the pressure loss is per 100 feet of pipe, and then we will multiply it by the decimal equivalency of the actual service length that we are going to use. So to determine the pressure loss in 100 feet, we will refer to the graphs that are located in the appendix of the Wisconsin Plumbing Code. And for this particular project, we're going to look for the graph that deals with type K copper, and that happens to be table 2 from the appendix. The next thing we're going to do is we're going to just take a look at the logistics of the table and the way that it's set up. What we're going to end up doing is putting or inputting the gallons per minute of the building, which is on the left-hand side. So step number 1 will be to input the gallons per minute of the building onto the left. We will find where that is, and then we will follow to the right, and we will intersect with the size of the service that we intend to run, which is step number 2. And then as we intersect, we'll then read that down to the bottom of the graph, where we will find step number 3 here. We will find the pressure loss due to friction in 100 feet of pipe. So the easiest way to use these graphs, I've found, is to use a sheet of paper and a right angle, and we will do our best to read through the graph as close as possible to the actual gallons per minute that we have for our project. Now, as you recall, we were at 22.2 gallons per minute. So we're going to do our best to find 22.2. So I'm going to go in here a little bit, zoom in a little bit for you, and we're going to go to 20, and then we're going to determine what's going on here with our breakdown. And so what I'm seeing right here is that this is 20. This darker line right here, this will be 25, and then the next dark line right there, that will be 30 gallons per minute. So we're going to go to 20, and then for this example, we're just going to go up 2 lines. Okay, we're going to call that 22. So 1, 2 lines. And now we'll take this corner and we'll intersect it with a 1-inch service. So we'll slide across. Okay, here's my 20. Here is my 1-inch. Now I'm going to go up 2 lines, And when I go up about 2 lines, here's 1 inch. We'll go up 1, we'll go up 2 lines right there. And then we'll slide over until we intersect that. Make sure we're at a right angle. And we'll read down to the bottom. And as I read down to the bottom, I'm going to just take my pencil and put a tick mark right there. And now I can kind of back out a little bit and I can see what's going on for pressure loss. So here we have 10 pounds of pressure per 100 feet. Here's 20 pounds of pressure per 100 feet. Our line intersects right here. This would be 15. So realistically, we're looking at about 13 psi of pressure loss for 100 feet of pipe. Okay, so we'll call that 13 psi. Okay, we're going to take this number and we're going to transfer it onto our calculation worksheet. And that's going to go right here. That is the actual pressure loss that we've found in 100 feet of pipe. We're going to multiply it by the decimal equivalency of the service length. Now, the example they give us there is that if we had 65 feet, we would use 0.65. Our service length is 75 feet long, so we will use 0.13 times 0.75. Let's try that. And we get 9.75 psi loss in 75 feet of 1 inch service. So that 9.75 will get inserted there. Now, our low pressure at the street was 58 psi, and so we will simply take 58 psi and subtract our 9.75 psi, and that will give us a new value of 48.25. And now our calculation sheet is calling for us to determine the pressure loss or gain due to elevation. Well, our water service is approximately 8 feet below our building control valve. So that means we're going to have to raise the water 8 feet. And for every foot that we come up, we will lose 0.434 psi. So we're going to take the 0.434 psi and multiply it times our elevation. And so we'll take 0.434 times the 8 feet. And just raising that water up 8 feet, we're going to lose just shy of 3.5 pounds of pressure. So we'll go with 3.47. 3.47. And we're going to subtract that from our subtotal. So I'll use my 48.25, subtract our 3.47, and at the building control valve, we have 44.78 psi to work with. And that will be what we will start the next section of this calculation worksheet with. And we'll put it down here. And that is the available pressure at the building control valve.